Hey guys, today we're going to talk about factoring. So some vocabulary that we're going to use during our talk about factoring, one of them is a factor, which are numbers that you multiply together to get another number. So when we look at the factors of 8, we have 1 times 8, 2 times 4, and then don't forget we can also do 4 times 2 and 8 times 1. Those are all factors of 8, or numbers that multiply together to give us 8. A multiple is a product of any number and a whole number. So I have listed here the multiples of 3, which are 3, 6, 9, 12, and that would keep going. It's kind of like skip counting. A prime number is a number with exactly 2 factors, which are 1 and the number itself, and I have the examples of 7 and 23 there. And a composite number is a number with more than 2 factors, and I have the example of 12, which can be divided by 1, 2, 3, 4, 6, and 12. Okay, so let's look at some prime numbers and composite numbers. So for prime numbers, I've got 3 examples. We already mentioned 7. It has the factors of 1 and 7. The only 2 numbers that multiply together to give you 7 are 1 and 7. 19, the factors of 1 and 19. Again, the only 2 numbers that multiply together to give you 19 are 1 and 19. And 47, the only factors that multiply together to give you 47 are 1 and 47. When we're talking about composite numbers, we're talking about different factors that can multiply together to make up this number. Okay, this number is composed of many different numbers. And what we're trying to do is take 8 and bring it down to what we call its prime factorization. So we want to take all the factors away and get down to prime numbers. Okay, because 2 is a prime number. So when we're doing this, I like to take away the biggest amount possible. And we're going to use our divisibility rules here. Okay. So, and what I've created is what's called a factor tree. So I've started off with 8, and since I know 8's an even number, I'm going to use 2. So I know that 2 goes into 8 4 times, so I have 2 times 4, which is 8. But I know that 4 is not a prime number. It is a composite number. So I need to break that down further, which we know that 4 is made up of 2 times 2. So the prime factorization for the composite number 8 would be 2 times 2 times 2, which most of you might remember when we were working with our exponent. So when we're doing a factor tree, make sure you circle all your prime factors so you don't lose them. Let's look at a few more examples. Let's look at 16. Okay, so with 16, I'm going to start off with 2 because I know 16 is an even number. So 2 times 8 gives me 16. So 2 is prime, I'm going to circle that. But 8 is not prime. We just talked about 8. We know that 8 is a composite number. So I know that 8 is made up of 2 times 4. So I know that 2 is a prime number. I'm going to circle that. And now I have to work with 4. Well, 4 we know is made up of 2 times 2. Both 2's are prime. So I'm going to go ahead and circle those. So 16 is made up of 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. Now, some of you might be thinking, yeah, but I don't want to use 2. I want to use another number. Well, if you want to use another number to get to the prime factorization of a composite number, that's fine. There are many different ways to do it. I just like using 2. I also like the factor tree. When you do it, it kind of goes down in a cascading downward pattern to the right here, kind of like that. So example 6, we've got 16 again, but this time we used 4 times 4 instead of 8 and 2. So when we break 16 down into 4 times 4, those are not prime numbers. We have to go a little further, and we know that 4 is made up of 2 times 2, and 4 again is made up of 2 times 2. So you still get 2 times 2 times 2 times 2, the same prime factorization. We just went about it a different way. So it is okay to use different paths to get there. Just make sure that the prime factors are all the same. Okay, let's get a little bit of practice in. We're going to look at determining whether these numbers are prime or composite. So go ahead, write these down, pause the video, work through using your divisibility rules, and tell me if these are prime or composite. Okay, let's go over them and see how you did. So for A, we have 29, and 29 is a prime number. The only factors that multiply into 29 are 1 and itself. The number 93 is a composite number. Okay? Remember the rule for 3? Just find out if something's divisible by 3, we take the digits 9 and 3 and we add those together. 9 plus 3 is 12. And if that result is divisible by 3, it is the entire number is divisible by 3. So 9 plus 3 is 12. 12 is divisible by 3. So therefore 93 is divisible by 3. And if we take 31, multiply it 3 times, we get 93. 117 is a composite number as well. Again, we can use the 3 rule. 1 plus 1 is 2, plus 7 is 9. 9 is divisible by 3. And we can actually use the 9 rule here, where we take 1 plus 1, which is 2, add that to 7, which is 9, and if the number is divisible by 9, it is also 9 is also a factor of that number, so 9 times 13 would give you 117. And then for D, 139 is a prime number. Okay? The only factors of 139 are 1 and 139. Okay, let's get a little factoring practice in here. Got 2 numbers for you to factor. So go ahead, write these down, A and B, and pause the video, take a minute, and when we come back, we'll review. Okay, let's go over the results, see how we did. So 24. Okay, again, I like to go use 2 on my even numbers, so I have 2 and 12. And 12 I know is a composite number because I can use 2 and 6. And then 6 is also a composite number because that can be broken up into 2 and 3. 3 is also a prime number. So for the prime factorization of 24, it would be 2 times 2 times 2 times 3. For 75, I knew that 3 went into 75 because 7 plus 5 is 12, and 12 is divisible by 3. So when I factor out a 3 out of 75, I'm left with 25, and I know that 25 is the perfect square of 5. So I know that the factors of 25 are 5 times 5. So the prime factorization of 75 is 3 times 5 times 5. Okay, folks, that will do it for factoring. If you need to re-watch the video, please remember that you can always come back and find it. We'll be practicing in class, and I will see you there. Os!